David Can here with another question in topic 1.1. We're looking at the process of estimation. We want to know what the best estimate is for the time it takes light to cross the nucleus of a hydrogen atom. And we're given a bunch of choices. Well, let's take a look at what we know. You may not know much about the size of a nucleus atom, of a hydrogen atom today. Although by the end of the course you might. But what you do know, or at least you should have access to, is the data booklet. And the data booklet tells you that the speed of light is 3 times 10 to the 8th meters per second. When we look at the answers, we're just estimating. So these answers are just to the nearest power of 10. So we're going to make life easy for ourselves, and we're going to approximate the speed of light as 10 to the 8th meters per second. And what we're going to try and do is we're going to try and reason out which of these is an appropriate time for something traveling this fast to travel across the nucleus of an atom. And we'll do that with a familiar formula. Distance traveled is velocity times time taken. So what we'll do is we'll compare the distance that light travels in these 4 times. So we have the velocity, which is 10 to the 8th. And we'll multiply it by each of these options. 10 to the negative 23rd, 10 to the negative 20, 10 to the negative 15, and 10 to the negative 7. Now keep in mind you won't have your calculator for your multi-choice test. So you will have to work with exponents. So when you multiply 10 to the positive 8 times 10 to the negative 7, you have to add those exponents. 8 plus negative 7 gives us 1. 10 to the 1 is 10. And we're working with SI units, meters per second, seconds. That's 10 meters. That's unlikely for the width of a hydrogen nucleus. I don't know about you, but I've never seen a hydrogen nucleus that's 10 meters wide. Let's try the next one. 8 plus negative 15 is negative 7. 10 to the negative 7 might seem like a good answer at first, but if we stop and think about it and start to compare it to things that we know that this is 0.1 micrometers. 1 micrometer is a good estimate for the width of your hair. So 1/10 the width of your hair for a hydrogen nucleus? Well, the nucleus is just the small center of the atom. So if a hydrogen nucleus were 1/10 the width of your hair, there could only be less than 10 atoms in the width of your hair. Much less than 10 atoms. Your hair couldn't have anywhere near the strength that it has. C cannot be a correct answer. Taking a look at B and A, it starts to get a little murkier. We get 10 to the minus 12 meters and 10 to the minus 15 meters. That's 1 picometer and 1 femtometer, respectively. Now we're kind of stuck, because unless you just happen to know a little bit more about atomic scale sizes, it's hard to reasonably guess which is the right answer. But what we have been able to do is narrow it down to a 50-50 choice. And a 50-50 choice on the multi-choice test is pretty good. Go ahead and take your best guess, move on. Flag the question to follow up if you have time. But what I'll go ahead and let you know is that A is a better answer for the width of a nucleus, 10 to the minus 15 meters. 10 to the minus 12 is closer to what we might expect the width of the whole hydrogen atom to be. So you have your nucleus in the center, that's your proton for the case of hydrogen, and you have your electron way out here in the orbit, in the shell. So 10 to the minus 15 is a little bit small, but reasonable for that distance. 10 to the minus 15 is about spot on for the width of the nucleus itself.